So let's go ahead and get started here. So in this section, we're going to talk about the maximum and minimum values of a function. Sometimes these are called the extrema, or extreme values of a function. So we're going to define two different categories. The first category are called the global extrema, or sometimes called the absolute extrema. So let's pick a number, any arbitrary number, in the domain of a function f. So if it turns out that that number we picked is the largest y value, has the largest corresponding y value in the function, then we're going to call it a global maximum. So we're going to say that an absolute maximum f is f of c if f of c is greater than or equal to f of x for all x in the domain. So we'll look at a picture here in just a second. But remember, interpret these as y values. So if I have a function here, let's just go ahead and put a picture up, I guess. If I've got a y value here, right here, this y value would be my f of c in this problem. Okay? Notice that the y value is greater than or equal to all of the other y values for this function. So then we're going to go ahead and call it a global maximum. We'll understand the word global, why are we saying that here in a little bit. Okay, similarly, we have a global minimum. And a global minimum is some value c where f of c is less than or equal to f of x for all x in the domain. Okay. So now we've defined global extremum. In fact, let's scroll down real quick and let's look at this function here. So for this function here, I want to go ahead and identify the global maximum and global minimum, if there are any. And in this case, there are. So we would call this value right here, this is a global max. Okay, so that, let me just be a little more vague here. Let me say that this point right here is a global maximum on this function. And this point right down here is a global min. Meaning of all the y values that show up associated with domain values in the function, this y value right here, negative 27, is the smallest y value. Likewise, of all the y values that show up in this function, for any of the x in the domain, this is the greatest y value. So that point right there would be labeled as a global maximum. Okay. Now, we also want to introduce what are called local extrema. Local minimums and local maximums. So these occur not on the endpoints, first of all, and you don't have to be the largest or smallest value in the entire domain of the function. You just have to be in a neighborhood. So let's go ahead and define this. Let f be a function with a domain D, and let C be an interior point. The word there is interior, point in the domain. This is important. Not all books choose to define local maxes and mins this way, but this is the way our author does. So I'm stressing that this needs to be an interior point. Okay. Then we would say that f of c is a local maximum if f of x, if f of c is greater than or equal to f of x, not for all x in the domain. This is where the definition is going to be different. Before we said it had to be for all x in the domain. But here we're going to say for all x in some open interval. Interval containing c. So there's some similarities and some differences to the definition of a local maximum as opposed to a global maximum. Okay. So you still have to be the greatest y value around, but only in some open interval containing the point. So let's go down here. Let's look at this function right here, and let's see if we can identify a local maximum. Okay. Well, first of all, I cannot pick x equals -1 to be a local maximum. How come? Because we said that it had to be an interior point. So we cannot include x equals -1. But there is a local maximum in this problem, and in this case we would say that this value right here is this point right here is a local maximum. Okay? How does this meet the definition? Well, first of all, notice that there are plenty of points. You know, for instance, this ordered pair right here, or this point over here, where the y values are greater than the y value at what we're calling our local max. Okay? So greater than this y value right here. But I can put an interval around the x value c. Okay, here c in this case would be 1. And around c I can put an open interval, and notice what happens there. On this open interval, we see that f of c is the greatest y value around. Okay, and now let's look at the definition of a local minimum. So a local minimum is going to be very similar to the definition of a local maximum, except we're going to reverse the direction of the inequality. So C will give the location of a local minimum if f of c is less than or equal to f of x, again for all x in some open interval. Containing c. Okay. So it doesn't have to be a local minimum. You don't have to be the smallest point in the entire function. It just has to be possible to construct a neighborhood around that value c so that it is the lowest value in that neighborhood. Okay. So let's look down here. Let's see if we can identify any. Local minimums. So it appears to me that we have a local minimum right here. So conceptually, folks, all we're saying when we're saying something's a local minimum or a local maximum is we're identifying the peaks and the valleys. That's a good way to look at it. But there's a precise math definition that we're using here. We're saying that c equals 0 is a local minimum because I can construct an open interval around c so that it is the lowest value in that interval. Okay. Are there any other local minimums on this function? Take a look. Yes, there is. There's one other local minimum, and it's this point right here, which was also the global min on this function. How does that work? Well, if I construct an open interval around that point c, notice that for this particular open interval, at c equals 3, it is the lowest point in the interval, meaning take any other ordered pair from that interval, and all of them have y values that are either greater than or equal to this y value here at c equals 3. Okay. So hopefully that clarifies the difference between a global max and a local max, and a global min and a local min. Okay. So to be a global max, let's just summarize that. To be a global max, you have to be the greatest point around the entire domain of the function. So this is a global max because there are no other y values in the function larger than it. To be a local max, like we have here, you just have to be able to construct some open interval, like I did right here, for which that particular x value returns the highest y value in that interval. Okay. One other thing to keep in mind, and this is per our author's definition, that local maxes and mins can only occur at interior points, which means that although an endpoint may or may not be a global max or a global min, an endpoint can never be a local max or a local min. Okay, folks, so now I want to look at this point number 3 that I made. And this is potentially a confusing topic. That in that regards, the location of the extreme value versus the extreme value itself. Okay? So I'm going to try and parse that out here in just a second. So if we look at this function, the ordered pair 1, 5, is a what? Well, previously we said that it is a local maximum, right? That this point right here on the function we could call a local maximum. That's perfectly fine. But how do I distinguish between the number 1 in that ordered pair and the number 5 in that ordered pair? So we would say that x equals 1 is the location of a local maximum. So we'd say that f has a local max at that x value. So the key word here, and I've italicized it, the most important word there is at. That is the location of the local maximum. We could also say that f has a local maximum value of 5. So in this case, I'm emphasizing the actual y value that is the local maximum y value, the local maximum value. So that's a value of 5. So that's where we're trying to make some distinctions here. So I'd like you to now pause the video and work through 3a through f. Give that a shot, pause it, and we'll resume here in just a second. Okay, so we want to give the location of any global maximum. So in a previous version of this picture, I've already identified the global maxes, the global mins, the local maxes, the local mins. But this problem is asking us to give the location of any global maximums. So as you recall, and as you probably already have labeled, we said that we had a global max right here at this point. Okay? So the location of the maximum is at x equals 1. Oops, excuse me. Is at x equals what? Negative 1. Okay? That is the x value of the global maximum. If I asked you to give any global maximum values, then the global maximum value is the value y equals 37 here. Okay. The next question asks in C to give the location of any global minimums. Well, we have a global minimum at x equals 3. That is, if I go to this x value 3, I input it into the function, it gives me the lowest value in the function. But this is the location of the global minimum. D asks to give the global minimum values. So we have a global minimum of y equals negative 27. That is a global minimum value. So we have a local minimum at x equals 0 and at x equals 3. We have local maximums at x equals 1. Okay? So let's say a couple things now before we form any misconceptions. For this particular function, we only had one global maximum and one global minimum. That's not always going to be the case. We might have several global maximums and several global minimums. Okay? Likewise, in this example, we did have two local minimums, but only one local max. That's just function dependent, how many you have of each. The only thing I want to emphasize here is that the local extrema cannot occur at the endpoints in this class. Okay. Do I have anything else I want to say about this? Yeah, I guess the other thing is I will not purposely try to trip you up with this idea of the location being at a place and a maximum value of. I'm not going to try to purposely confuse you with that, but you should know the difference between the two. Okay. For those of you that are interested, there's a nice little point here that describes how different textbooks might choose to define their local and global extrema, and you can read through that if you wish. And if you're ever interested in that, feel free to come by and we'll discuss it.